Imagine flying over a massive, desolate stretch of red earth in the arid lands of Namibia. You're expecting to see, I don't know, a random, broken ecosystem patches of struggle and survival. But instead, you see patterns, perfect pattern gaps, hundreds of thousands of them, dotting the landscape with this uncanny uniformity.
It is genuinely one of the most visually mystifying sights in the natural world. These are the Namibian fairy circles, and the visual mystery is so profound that, well, local legend refers to these formations as nothing less than the footprints of the gods.
Which is a fantastic starting point. And today, we are diving deep into this botanical puzzle that has actively stumped scientists for decades.
For decades. And our mission today is ambitious, but I think really clear. We want to synthesize the core facts, define the very strict criteria for what makes a true fairy circle.
And then critically assess the, four major competing hypotheses?
The four big ones, yeah. The goal is for you to walk away with a deep understanding of what we know, and maybe more importantly, understand why settling on a single definitive answer has been so uniquely challenging. This isn't just a ring of bare dirt, it's a window into how nature organizes itself under extreme stress.
Okay, so let's start with the hard definition. When we talk about these circles, where exactly are we, and what kind of scale are we dealing with?
Well, the scale is massive. These formations stretch across thousands of square kilometers of arid grasslands, running through Namibia and into parts of southern Africa. And their individual size, they typically range from about 2 to 10 meters across.
Which is a pretty decent size for a bare patch of earth.
It is. And what gives them that characteristic pattern is their spacing. They don't just cluster randomly.
Right.
They maintain their distance, spread out roughly every 5 to 10 meters. And that creates this strange, almost intentional visual rhythm across the landscape.
Like a massive organic grid system.
Exactly. And the scale isn't even uniform, which just adds another layer to the mystery. The further north you go, say, into regions like Angola, the circles become significantly larger. Some outliers have been documented reaching almost 40 meters in diameter.
Wow. And when you combine that uniform spacing with the fact that they are just empty gaps, especially from the air, the formation is striking. It creates this distinct, almost mathematically precise hexagonal pattern.
And that hexagonal pattern is absolutely key. What's fascinating here is that scientists have established very strict criteria. Not every circular gap is a fairy circle.
So if we're going to study the real phenomenon, we have to apply some non-negotiable standards.
3 of them, yes. First, they must be empty gaps in a grassland without a central insect nest structure. If there's an anthill or a termite mound in the middle, it's not a true fairy circle.
Okay, that's clear.
Second, they have to have the ability to form spatially periodic patterns. That means exhibiting that hexagonal rhythm we just mentioned.
So an isolated, lonely circle doesn't count unless it's part of a larger repeating pattern.
Precisely. And the third criterion is maybe the most restrictive. They are confined to a very narrow, very specific arid climatic envelope. They only appear in places receiving between 50 and 150 milliliters of rain annually.
50 to 150 milliliters. I mean, to put that in perspective for you listening, that's almost nothing. London, for instance, gets over 600 millimeters a year.
Right.
So this grass is surviving in a climate that is getting less than a tenth of the rain a temperate climate gets.
You're absolutely right. That climate envelope is crucial. It suggests that nature has to be stressed just the right amount, pushed almost to its breaking point for this specific thing to happen.
And before we move on, we have to mention the other ring people often confuse this with, the fairy ring.
Ah, yes, the fungal ones. Fairy rings are those, beautiful, otherworldly-looking halos of mushrooms you see pop up in forests or on lawns. We understand that mechanism very clearly. The mycelium, the underground sort of root-like network of the fungus, grows outward in a circle.
And as it grows, it uses up all the nutrients in the soil directly behind it.
And when the nutrients are gone, the center of the ring dies off, leaving that circular boundary of healthy fungi at the edge. It's a biological certainty. A predictable process.
But the fairy circles, by comparison, are still a complete biological mystery.
We have no such certainty.
And this is where the real challenge of the puzzle lies. And it's a surprisingly simple one. The reason this has been so tough to unravel is fundamental. No one has ever actually witnessed one in the making. We have zero time-lapse footage of a fairy circle being born.
None. And that difficulty is hugely compounded by the logistics of the location. They only occur in those remote, highly arid areas. Mounting a continuous multi-year observation campaign in that environment is It's just a monumentally difficult and frankly very expensive undertaking.
It's hard enough to get a team out there for a few months, let alone camp out for a decade waiting for a circle to form. But what we do know about their history is truly stunning. It speaks to their incredible resilience.
Their stability is what defies typical ecological understanding. You look at grass. It's ephemeral, it changes, it moves, it dies, it recedes. But the bare center of a fairy circle will stay naked, without moving or changing size, for potentially 100 years.
A century. A century of permanence for a simple patch of dirt surrounded by temporary grass. That's a shocking level of stability in an ecosystem, isn't it?
And we have hard data to back that up. One study looked at these formations using aerial photography over a 50-year period, and the conclusion was staggering. 97% of the circles remained unchanged. They didn't shrink, they didn't move, they didn't fill in.
97% over half a century. That suggests the boundary of those circles isn't temporary. It's somehow fundamentally imprinted on the landscape itself.
It's more than just stability against time, it's stability against climate stress. That stability holds up even after severe multi-year droughts. When the surrounding grasses died off completely, when the whole landscape looked ruined and the rain finally came back, the grass grew back in the exact same circular formation.
The invisible boundary was maintained even when the grass was gone.
It was.
That's just amazing. So if these circles are so stable and permanent, resisting time and drought for decades, how could they have possibly formed in the first place? Let's get into the competing science.
All right, so we have 4 major competing hypotheses. And for you, listening, it's important we look at each one and then immediately apply the scientific counterargument.
Let's start with the obvious one. The engineers of the underground world, termites.
Theory number 1, the insect explanation. This hypothesis suggests that termites are the architects. The idea is that the termites clear the grasses in the center to allow that precious, sparse rain to accumulate underground, giving them crucial long-term access to water.
Which sounds perfectly plausible. I mean, termites are brilliant engineers.
Yeah.
But if they're the cause, they have to be there, right?
And that's the core counterpoint. The theory doesn't hold up consistently because intensive field studies have shown that termites are simply not always present where fairy circles are found. If termites were the required cause, they'd need to be in every single active circle, or at least leave reliable evidence. And they just don't. That inconsistency is a major flaw.
Okay, so that takes the bug-based theory down a notch. Theory 2 tackles the botanical side directly. Clonal plants. The aging root theory.
Right. This one looks at how some arid grasses self-replicate. They send out these specialized underground stems called rhizomes, which are essentially cloning themselves by sending up new sprouts. The theory claims that over time, as these roots age, the central older sprouts die off. It's a process called senescence.
So it's a self-inflicted bare spot caused by the plant's own life cycle. It sounds elegant. What's the evidence against it?
The evidence against it is highly technical, and it comes from genetic testing. If these bare spots were truly created by a single plant cloning itself, all the grasses right around the circle should be genetically identical. They should come from the same rootstock.
But I'm guessing they weren't.
You guessed correctly. A study found high genetic diversity in the grasses surrounding the circles. They're not clones. And this strongly suggested that while clonal rings do exist, and they look similar on a small scale, they are not the true spatially periodic fairy circles we're talking about.
That's a great distinction to make. Okay, theory 3. This one gives us a decidedly non-biological explanation. Hydrocarbon microseepage.
This theory takes us underground, suggesting a purely geological mechanism. It hypothesizes that gases, things like methane, propane, butane, are leaking up from deep below the earth. And the constant seepage of these gases into the topsoil just kills the grasses.
The slow leak poison patch. A fascinating idea. But this is the one theory that feels a little less targeted. What's the main pushback here?
Well, the pushback is twofold. First, the distribution. Hydrocarbon seepage usually occurs along geological fault lines, not in a highly uniform, mathematically precise, hexagonal pattern across thousands of kilometers. And second, consistent chemical testing has been inconclusive. They just haven't reliably detected the concentration of gases needed to sterilize the soil for 100 years across the whole range.
So it's a possible mechanism, but it struggles to explain the sheer scale and the precision of the pattern. Which brings us to theory 4. Spatial self-organization. This is the one that has gained the most traction, and it taps right back into that core problem. Water stress.
Absolutely. This hypothesis treats the circle not as a problem, but as a brilliant solution. It's based on the measurable fact that the center of the circle does have a significantly higher moisture content. The theory suggests the grasses themselves grow in this distinct pattern, they self-organize, to efficiently capture and concentrate that scarce moisture with their roots.
So the grass is actively engineering the bare patch. It's a mechanism to capture water.
Exactly. The grasses on the rim of the circle are the beneficiaries. The bare center acts like a giant cistern, allowing water to get deep into the soil, and the grass then clusters at the edges where that water is most accessible. This means the rim of the circle becomes, prime real estate, where grasses compete fiercely for a spot.
And that constant high-stakes competition is what reinforces the geometric pattern.
Precisely.
This is where we have to introduce the crucial global evidence, because for decades, this was all seen as just a strange Namibian quirk, a localized phenomenon.
And that changed everything. In 2014, the discussion fundamentally shifted because fairy circles were suddenly discovered 10,000 kilometers away in the remote outback of Western Australia.
Australia, I mean, the geographic distance alone is staggering. What did the scientists find when they looked at these new circles?
Despite the vast distance, the spatial pattern of the Australian circles was essentially the same. The size, the hexagonal distribution, the incredible geometry, it all aligned almost perfectly.
So if we look at our competing theories, this discovery acts as a filter. If the cause was specific to one continent, like a specific Namibian termite or a local clonal grass, then that theory is pretty much invalidated, right? Because those things don't exist in Australia.
That is the key insight. The common denominator between these two incredibly distant locations isn't a specific bug or a specific grass or even unique geology, it's the climate. The only major fact they share is that hot, extremely dry climatic envelope, that 50 to 150 milliliter annual rainfall.
So if the effect is global, the cause must be universal. This geographical evidence strongly suggests that the self-organization theory, grasses creating a pattern to manage intense water competition, is the most robust explanation.
It's the most powerful candidate because it's a universal solution to a universal problem, surviving extreme aridity. And it manifests in this predictable, beautiful, mathematical way across continents. The environment forces the pattern.
It's a testament to the elegant efficiency of nature. But we should add the caveat, right? Even with this evidence, the scientific community is still debating.
Oh, absolutely. More studies are needed before any definitive, close-case conclusions can be drawn. The data points towards self-organization, but the debate is far from over.
So what does this all mean for us? I mean, regardless of the precise mechanism, the fairy circles continue to enchant observers with their magically mathematical arrangements. This deep dive really illustrates how nature so often defaults to geometric precision, even in the most remote and resource-scarce landscapes.
And the final takeaway for you is this. We are certain of their extreme permanence, we are certain of their unique climatic distribution, and we're now certain that this pattern is replicated thousands of miles apart. Those certainties give us a very strong indication that climate and water stress are the primary drivers, even if the precise agent is still debated.
So here is a final thought for you to mull over. If that self-organization theory is correct, if grasses in this specific, highly constrained range of aridity will always find this geometrically perfect way to distribute water,
Then what other seemingly random yet geometrically perfect natural patterns might we find in other arid climates that we simply haven't noticed yet? Should we be using that confined, narrow, arid climatic envelope, that 50 to 150 milliliters of rain, as a guide, to actively search for similar undiscovered phenomena elsewhere? Because if the pattern is universal, the footprints of the gods might be showing up in deserts all over the world.